So yeah, I work on the Elastic Beanstalk team at AWS. I've been with Amazon for a little over 3 years now. And who's used Elastic Beanstalk before? Who's used OpsWorks? Fewer. How about CloudFormation? Okay. How about just raw EC2? There we go. The numbers follow like the expected. So Elastic Beanstalk is a service that's been around for about 3 years, and Beanstalk is all about taking these core infrastructure services like EC2 and VPC and RDS and S3 and CloudWatch, and basically leveling up or distilling all of the APIs. There's hundreds of APIs between these services, and saying for the applications that you want to run, there's maybe 40 APIs that that you would want to manage or that you would really care about. So Beanstalk is kind of making an effort to take all of these core services and combine them into one cohesive logical unit that is really focused on you deploying and managing web applications. So these could be Java apps based on Spring, PHP apps, web GUIs, API backends, and async workers. So we're going to talk about the three use cases there, but that's really kind of the target market for Elastic Beanstalk, what we'll talk about today. If you're deploying web apps or APIs, there's a few different environment types that Beanstalk presents to you or lets you use. The first is this, what we call single instance, and I'm going to just kind of walk through this architecture diagram and tease out the individual like core AWS services that Beanstalk is exposing to you. The first thing here is an auto-scaling group. So an auto-scaling group is a service inside EC2 that's been around for more than 5 years. And auto-scaling is all about growing and shrinking capacity, but it's even useful when you have a single instance, when you have one EC2 server. Because if this EC2 instance dies, what should happen? It should come back up, it should be resolved. So we still use an auto-scaling group. We set the min and max to 1. You notice that there's a DNS name. So every Elastic Beanstalk web application gets a DNS name. And bonus points to anyone who can tell me the AWS service that manages DNS. Route 53. So we use Route 53 to expose the CNAME for your application, and it's not routing to an Elastic load balancer in this case. So we're using an Elastic IP address, EIP, which is a static IPv4 address, and we slap it on your EC2 instance. Inside the auto-scaling group, we expose monitoring metrics. What's the service that AWS uses for monitoring? CloudWatch. So CloudWatch exposes metrics for monitoring and scaling your application. Logging, we will allow you to pull logs off of an EC2 instance into S3, but there's a new feature of CloudWatch called CloudWatch Logs. We're going to talk about using that with Docker in the demo here in a few minutes. And then alerting via the notification service. So when something happens, like the EC2 instance goes away or your application scales, Beanstalk is just taking all of these services and binding them into a cohesive unit for you. So single instance is really great for my WordPress blog that only my grandma reads. 1 T1 micro is totally sufficient. For dev and test, it's usually a pretty good choice. And then the next environment type is load balanced and auto scaling. And you can toggle between these two environment types. And in a load balanced and auto scaled environment, you still got your DNS CNAME. It's pointing to an Elastic load balancer in this example. And you choose the scaling parameters. And if you've used auto scaling before, auto scaling has a lot of different parameters, and you can configure it and fine tune it via the API or the management console. But we say you're deploying a web app or an API, there's a few things that you really care about. Minimum, maximum, the number of instances that are there right now, and how you should add or remove instances based on load. So we're giving you kind of an opinion on how you would use auto scaling for a web application. And then the third environment type is what we call a queue-driven worker today. So who has used SQS before? Simple queue service. It's a pool-based queue that is exposed by a web API. And the queue-based worker, you notice there's no Elastic IP address or ELB here. We are on the hosts in the Beanstalk environment running an agent, and the agent takes care of efficiently polling the queue for you. So running the optimum number of threads, pulling messages in batch from SQS, really optimized by AWS developers for maximum throughput from SQS. And then we're doing kind of a neat little trick on the box, and that is just redirecting them or posting them to localhost. So what this means is you can write asynchronous batch process workers in Sinatra or Django or Flask or Spring. So if you're a web developer, you're probably used to using these web frameworks. So queue-driven worker is about kind of allowing you to adapt your web dev skills to do these kind of more asynchronous workloads. A good example here is if you were collecting information in a form and you wanted to send an email to that user or that customer via SMTP or a simple email service, you might not want to do that as part of the request response lifecycle. If the SMTP server's down or there's a queue or it's backed up, you might want to queue that work to happen later. So worker tiers are good for those kinds of things that shouldn't happen as part of a UI request response lifecycle. So those are the three big environment types that Elastic Beanstalk gives you. Before Docker came along, before it was a twinkle in anyone's eye, Beanstalk supported Java, .NET, Node, PHP, Ruby, and Python container types. So we took an even more opinionated stance on, you've got a Python application, you have some modules or dependencies that you would express in requirements.txt, you would have the WSGI interface to the application, and we sort of configured the EC2 instance to run that way. But then Docker came along. So we have all of these customers who have been asking for, I don't know, Glassfish or Jetty or Netty, or if you look at the matrix of possible like servlet containers or web servers and languages that people would want to use, it's almost infinite. And we don't have an infinite amount of resources to custom tailor and custom build these container types. And so Docker is an obvious, like, perfect solution for that, to allow customers to define the process exactly the way they want it and run that process inside Elastic Beanstalk. And the other big win that we see here that I'm personally a huge fan of is fidelity. I know all of the container types like the back of my hand. I know exactly how they work, and there's still sometimes when I do something like that's not to the convention that Beanstalk uses. And it might work because I've got RVM set up on my laptop or virtual env set up some particular way, and it's not exactly the same in Beanstalk. And so what I've got working on my laptop doesn't work when I deploy it, and I have to resolve those problems and fix it. With Docker, that fidelity is there. I'm using Docker V1, I'm deploying to Docker V1, deploying a container, and it just works. So we're excited about that. Who's deployed a Docker container to Beanstalk before? I'm going to talk about the three kind of models that we support for deploying your applications to Docker. The first is the simplest. Give us a Docker file. So when you make an API call called create application version, you can just send a Docker file up. And we deploy that Docker file to the EC2 instances. And if you have a single instance environment, it goes to 1. If you have 10 instances in an auto-scaling group, it goes to all 10. And what happens when you send a Docker file to an instance? Does that just magically work? You gotta do Docker build, and then Docker run. So not the most efficient model, right? That first run, we're gonna do a Docker pull on all the EC2 instances and then do a build. The subsequent run is gonna take advantage of Docker caching, but a really easy way to get started. If you're using the Docker Hub or a third-party repository or running your own, then we support a manifest. I'll actually get back to context in a bit. So we've got this manifest file we call dockerrun.aws.json. It's a JSON file or a JSON document, and you describe how we should run a container. So you tell us what the repository and image or tag name are, if you have ports that need to be mapped, volumes that need to be mapped. So it's basically, if you were doing Docker run on your laptop, you're telling us how to do Docker run on your behalf in an Elastic Beanstalk environment. And then for both the Docker run manifest and the Docker file, you can of course include the context. So you can push a zip file up that has everything inside. So if you're using add commands or copy instructions, then you would include your zip file there. We'll actually look at a few examples of doing that during the demo. So the Docker run.aws.json file, really simple example of that. Like any good manifest, we've got a version number here, and we rev that when we add or change the members that we support. But in this sample, in the hub, I'm user Evan P. Brown, and I have an image called A Media Manager, and This update flag just indicates if we should do a Docker pull every time to see if it's changed. So we don't rely on the cached version exclusively. You can change that to false and just let the EC2 instance not phone home and check for an update. Ports allow you to define the port that the image exposes. So in this port mapping, I'm saying this image was built from a Docker file that exposes port 8080. And this is important because if you kind of peel back the surface of the EC2 instances, we're actually running Nginx in a reverse proxy mode on the host. So Nginx is receiving HTTP requests from a load balancer, and then it's using streams or upstream to route those requests to the Docker containers on the EC2 instance. So you do need to tell us the ports that are being exposed. If you deploy a Docker file and we see an expose in the Docker file, we'll peel that out and make the assumption based on what we see in the Docker file. So you've got some flexibility in either building from Docker file or telling us how to run a container via this manifest convention. So the advantages that, the things that I like about running Docker inside AWS are access to kind of the ecosystem, the other AWS services. So I want to run web apps or I want to build APIs, but it's the ability to connect to these other things in all of the other regions around AWS that I think is pretty powerful. Some samples and the bolded examples here we'll look at in a demo, but if you want to run Docker inside of a VPC, so VPC is some might call it a software-defined network. It's a service that allows you to find subnets and routing tables and security groups, optionally connect that network back to an on-prem network via VPN gateway, have private subnets with non-routable IP addresses. You can do that with Elastic Beanstalk. DynamoDB is a NoSQL or kind of a key value data store. You can access and use DynamoDB pretty easily from within Docker. We'll look at a sample app here in just a bit. Who uses RDS? Postgres, MySQL, SQL Server, and Oracle. So 4 sort of database engines that are fully managed. They run on top of EC2, but we're giving you a managed relational database. And then you kind of just connect to it with Beanstalk and Docker and use it, start writing to it, or reading from it. CloudFormation is an orchestration service, so it allows you to define the whole breadth of your application from VPC to RDS in a template file, and then run it. You can distribute it to your friends or run it in Tokyo and Sydney and Virginia. Supports Elastic Beanstalk and Docker. And then CloudWatch Logs is one of the newest services that we launched. This was at the summit in New York, I think 2 or 3 weeks ago. And this is the ability to access streaming logs. So logs on a host are streamed up to CloudWatch, and they're searchable from within the management console, or accessible from within the management console. And we'll look at a sample of wiring up CloudWatch logs from a Docker environment here in just a second. So I did promise in the meetup description that we'd be light on slides and more heavy on demos and Q&A. So those are my slides. I'm going to do the demo now, and then we'll come back to questions and answers. And I'm going to do the demo in the least formal way possible. I'm going to disappear. Let's sit right here. Can everyone hear me in the back?
Yeah.
Still good? All right. So I want to cover two big things. The first was accessing a data store. So DynamoDB. So if we wanted to build a Docker-based application in Beanstalk and store some data inside DynamoDB, how could we do that? How can Elastic Beanstalk sort of facilitate accessing these other AWS services? So I have a sample application up on GitHub, and we've done some videos on this. So I'll give you the link to the blog, and we've got this stuff blogged pretty extensively. This is just a simple Flask Python app that is, I'm just making you work on this microphone stuff, huh? I'll switch positions in like 3 more minutes. So this is a Python-based app. We've Dockerized it, and this application uses DynamoDB to store information that's collected from a form. So we need to have our application basically provision these dependencies for us, and we don't want to do it manually, right? Like, of course, I can go into the management console, and I can click services, and I can go find DynamoDB, and I can click create table, and I can define like the properties of this NoSQL data sort. I could write a really good wiki article on how to do that and hope that the other devs on my team follow it. But right, that's not repeatable, and we want this process to be repeatable. So Elastic Beanstalk has, as much as we have an opinion on how you would run an application, we expose kind of the underpinnings. We expose the EC2 instances, and we expose the ability to customize everything about the environment if you want to. So it's an optional thing. And this customization bit is really kind of hidden inside this dot folder. So it's called .ev extensions. This is inside our application source. And EV extensions are YAML formatted configuration files that allow you to define like the other things that you want to use with your Beanstalk application. So I think I've got one config file in this extensions directory. I called it setup.config. So this is a declarative language, and in this declarative bit, we've defined some resources that we need. This resource is we call it startup signups table, and it's a AWS DynamoDB table. And like everything I was going to do in the management console, and I'm going to just level up here. Yeah, that's better. It's like Meerkat Manor meets live demos. It's a new reality. If anyone wants to take that and run with a new reality show, I'll do your first episode. So this is all the stuff we would do in the management console to create that DynamoDB table we can define in this file. So Dynamo has a schema, so you've got to have a primary key and define the type of the primary key. So email is the name of the primary key, it's a string. Dynamo is unique and powerful because you tell us how fast the table needs to be, like how much throughput in terms of reading and writing it should be. I've gone the super conservative route here and said this table should have a unit of read capacity, so 1 read per second, and a unit of write capacity, 1 write per second. This application also needs a queue, and it needs an SNS topic. So again, AWS resources that you could create manually, but by declaring them in this configuration file and bundling it with our application server, when we deploy it, Elastic Beanstalk will provision these things for us automatically. The other like kind of gluing the bits together here, if Beanstalk creates this Dynamo table for us, our application needs to know how to connect to that Dynamo table, right? It needs to know the name of the table that gets created and where it exists. So as part of the extensions model that we've got here, we can create files on a host. So after we've created all of our resources, like our Dynamo table and our queue, we come in here and declare that var app.config is a file that should be created. These are the permissions that it should have. And this is the content of the file. So this is just a key equals value configuration file that's being written to the host. And there's one trick, there's sort of a problem with this, and that is this is actually on the EC2 instance, right? Because we don't know what's happening inside your Docker container. We don't know if there's a var app directory. So this is going to happen on host. So we need to take advantage of volume mappings or bindings to connect this configuration file and make it accessible inside your Docker container. And the place that we do that is back in our manifest file. I need to switch off the master branch and go to the Docker branch. But we talked about docker run.aws.json. One of the things we care about here is saying, hey, there's a host directory called var app, and that needs to be mounted into the Docker container because there's a configuration file there. So the net effect of this is that in this Git repository, we've defined exactly what the application is from the Docker file, which is here. So here's the process. Here's how the process should run. And then in EV extensions, here are all the dependencies that the process has. So anyone can take this repository, clone it locally, deploy it, and you're all going to get exactly the same thing. You can deploy it to the region in Virginia, or Oregon, or Northern California, or I forget all of the regions around the world. There's like 8, and you're going to get the exact same thing every single time. And what's really cool is if you decide that, you know, we're going to go into production, and actually 1 read per second and 1 write per second is not enough. We're probably going to want to edit this file, change the read capacity or the write capacity, commit it with a nice message, and push it, and hopefully it's going to go into CI, and Jenkins is going to check it out and test it. It's going to get pushed through our pipeline and promoted, and there's attribution that Evan, you know, changed the capacity, and he did it for automatically, and we can revert those changes. And we're really minimizing, as cool as pointy clicky is in the management console, we're trying to minimize that and make these things more declarative and repeatable and version controllable. So that's kind of a first look at EB extensions. Pretty much anything that exists in AWS, pretty much Elastic's there. Most things you can declare in these config files, bundle them with your app, and have beanstalk provision them on deploy. So to deploy this application, we could go to releases and download a zip file, and we could upload the zip file from within Elastic Beanstalk. I'm a big fan of, I use Git, and especially for these interpreted languages, my development workflow is very dependent on Git and branching feature branches and merging those in. So I use EB. EB is a command line tool that we publish that integrates with Git and pushes, binds your Git repository to Elastic Beanstalk and runs it. So let's git clone this repository.
You're on that wireless?
I was on the wireless, unless I got quarantined again. That's on. All right, let's do this push right. Just doc cloud. There we go. All right. So just to get repository, if you've seen the talk I did at DockerCon, you can close your eyes for the next 30 seconds. It's the same thing. It's a local Git repo. It doesn't know about Elastic Beanstalk. So using the EB tool, we need to initialize a directory. Making API calls to Beanstalk takes credentials. These credentials are in my local environment, so they're showing up. I'm going to deploy to Virginia. Let's say Evan's demo app is the app name, and this is Evan's demo prod is my environment. Notice that that's way better. Web server or queue-driven worker, this is a web server. Load balanced or, right. Yep, got it. So we've got all of these different, we call them solution stacks, so PHP, Python, Ruby, Node, number 53, I think, before I went on vacation. Docker 1.0 was number 53, it still is. I think it's alpha sort, so no offense to the Docker folks. This is a load balanced environment. We don't want an RDS database, and we're going to just kind of default through these things. So we've told our Git repo, our application, that it should run in Beanstalk and how it should run, and how we can EB start. I'm not going to deploy the latest commit, but this is making the API calls now to Beanstalk and actually starting an environment with the configuration that we defined, and basically doing a Git archive and uploading that zip file to Beanstalk. Yeah. So once it starts, we'll do an EB push, and it will push the current branch that we're on. Thanks for asking. So we flip over to the console now. We see this gray. So this is kind of the vocabulary that we use can be a little non-intuitive if it's the first time you're using Beanstalk. The higher level construct is an application. So Evan's demo app, and an application has an environment or multiple environments. So an environment is an instance of your application, a load balanced or single instance environment. You can have multiple environments inside an application construct, but it's really kind of your deployable thing. So it's in gray mode right now, so it's deploying. With the Docker logo, we can see the version of Docker that's running on top of Amazon Linux, and it's going to take 10-15 minutes to launch, so I'm not going to sit here in silence. I've got an environment that I launched when I was eating my banh mi earlier, and it's ready to go. And this is actually a different application, so we're going to pivot over to a slightly different application and talk about some of the things we could do with CloudWatch logs. And this is a PHP app. And PHP app is also on GitHub, and we talk about it on the blog that I'll link to here in just a bit. It's also got a branch that's specific to Docker, because these applications existed before we had Docker support, and so we Dockerized them, and it's kind of nice to compare the branches and see like what it took to Dockerize a PHP or Python app. In this PHP sample application, it's much more traditional. It's a form that writes to a database, writes to MySQL, and Beanstalk has via extensions support for provisioning an RDS database with your app. An RDS database is a little different. Like a relational data store is a little bit different than a NoSQL or key value data store. In what major way? Like what is different? Has a schema. Someone said it has a schema. It's got a schema. So we have to apply the schema to the database at some point. Again, we don't want to like launch MySQL Workbench and do like the create tables or create the schema manually. We want that to happen programmatically. So again, using EB extensions, I'm going to actually pop into TextMate here. We have a config file. And again, so like it's Docker based, but we don't know anything about the container that you're running. So we can't assume that you have the MySQL binaries installed on your host. So the configuration files allow us to define packages to install on the EC2 instance. So outside of the container boundary, we're using the Yum package manager to install MySQL. And then we're running this script. It's in the EB extensions directory, and it's called deploy schema.sh. And any guesses why that highlighted line is important? Yeah, you don't want to run on all 10 in your load balance and autoscale group. It just needs to happen once. Like if you're doing rake DB migrate or the Django equivalent, like schema migration should ideally happen once from one host. So leader only. Beanstalk does leader election. It picks a host. An important thing to note about that, if you use leader election, is that it's not necessarily the same leader every single time. So when you go through deployments, an instance could go away and come back, could scale down and go away. So we can't, guarantee that the leader's there every single time. So it's a minor detail, but it is important. So we're basically saying on one host, run this deploy schema script, and here we're just running MySQL. Notice that for an RDS database, if you use RDS with Elastic Beanstalk, we inject the information that you need to know as environment variables. So the host name, the username, the password, and the port are available in the environment. Anything that's passed into a Beanstalk environment is also passed into your Docker container. So if you pass an environment variable into your Beanstalk environment, we'll propagate it into your container with the -e args. And we're just calling create table. And then the last thing I'll talk about, we can actually look at this simple application, share your thoughts. This works. Haven't tested it on the network. It works. Success. There we go. So we've written the RDS from our Docker container. If we look at the Docker file, again, just defining the process, this container, this image, or the image was built on the host from the Docker file, and we run it on the EC2 instance for you. Who's heard about CloudWatch logs? So this is like the last integration piece I want to talk about. CloudWatch logs allow you to run an agent on an EC2 instance and push logs. So push instead of like sending them to S3, push them into a stream in CloudWatch logs. A stream can be like a name, so var log messages could be a stream. If you have a bunch of EC2 instances, a stream could be an instance identifier. So if you've got 20 EC2 instances, you have an EC2 instance ID, that could be an individual stream. We aggregate those logs in CloudWatch, and you can look at them, which is fun. And you can define metrics on them, which is really nice as well. So this PHP sample app, what was the web server I said was running in front of Docker? Nginx. Nginx is running. Nginx has some pretty useful logs. requests like gets and posts to the app, static asset requests like our style sheets and our JavaScripts. 3 weeks ago, if I wanted to get those logs, actually it wasn't terrible. I can do, well, let's do it from the management console. I could go to logs, and I can click snapshot logs. This has been around for 3 years. We basically send a message to each host, and we pull the logs into S3, and then you have a log file that you can look through. But you can't really, like, this isn't actionable. You can't say, I see a lot of 503s, someone should get alerted. Or I'm seeing a lot of 200s, we should scale out or scale in. This is just like debugging, basically. CloudWatch Logs is debugging, but it's tied into alarming notifications and scaling metrics. So one of my favorite new features about Beanstalk is these extension files, these config files. They can just be YAML files, that's fine. You can also include a zip file, which is a collection of config files that define some functionality. And the folks on the CloudWatch log team said, hey, we've built a module or a plugin for Elastic Beanstalk that will just automatically support CloudWatch logs. I did a wget and downloaded the zip file into my EB extensions directory and did a push. I could open up the zip file and look at the configs and how they wrote them, but it's several hundred lines of YAML to like install the agent and identify the streams and where the Nginx logs are. We just don't care about that. So this is the first example of us sort of publishing a package extension, and definitely look for more of that. But it was a wget from the documentation into my extensions directory, and I did a push. And what happened was I didn't have to go to CloudWatch and create a CloudWatch log stream. I didn't have to install the agent on each EC2 instance, which is totally impractical because if we're auto-scaling and we add a new host, it has to happen automatically. And the way CloudWatch logs really manifest themselves is in the logs submenu. And we have log groups. So I have a log group for this PHP Docker app. I have one instance in this environment. We'll look at how we like scale out and scale in and watch a new stream show up. But this log stream gives us, just to prove it, I did this at 6:20 right before Victor came on. I downloaded the zip file and it started aggregating and pushing them out. In some cases it takes about a minute for the new log entries to show up in CloudWatch logs, but it's pretty swell to get raw access to these logs. So we do it for Nginx by default. Yeah.
Can you search also here, or is this still in beta format?
So it's not in beta format, but it's out there. It's only in US East right now.
Yeah.
They'll be expanding that, and I'm not sure when search is scheduled, but I'll definitely add a +1 to the CloudWatch team that you've asked for search. Yeah, it would be nice.
Can you ship CloudTrail logs there?
CloudTrail logs, not yet.
Yeah.
Not yet. But I know I sit next to the guy who prioritizes features for Beanstalk.
He's
I'll let
working
him
on
know. CloudTrail is a service that aggregates API logs. So if you call create instance or create Beanstalk environment, it's all about the operations that you perform on the AWS APIs, logging. So log streams are great. I could come in and define a CloudWatch alarm that says if HTTP 200s are high or 503s are high, send an email or scale out or scale in or kind of whatever you want. Your regex foo needs to be fairly strong because, right, you got to define a regex to pull out from each line, like what matters, but the logs are there. They're in the console for you to access. If I wanted to scale this Beanstalk app, we expose these config panels inside the management console. And again, like 100 different APIs for auto scaling in EC2. There's a lot of power there, and we've distilled it down to like 6 things. How many at a minimum? How many at a maximum? You probably don't want to run 4 EC2 instances in the same availability zone. Like an AZ is a physical data center, you want to spread those out. So I could say run this anywhere, or I could be really specific and say any 2 or any 3. For like maximum bonus points, why would I want to be selective about the individual AZ that I choose? Prices are uniform across zones, but it has something to do with pricing. swing spot, reserved instances. If you purchase a reserved instance, which is reserved capacity, you purchase it for a particular zone. So if you have RIs in US East 1A, you want auto scaling or beanstalk to run there. So you can pin that down if you like. Scaling triggers, so we expose a scaling metric. So if you're CPU bound or request bound or whatever your application characteristics are, you define how to scale out, so add capacity, and in to remove capacity. So I didn't, so what did I do here? Any three shows divided UI persona here when I get back. Copy. That stuff. So go back to the dashboard, and we'll see from our event logs that this is kind of taking place. I said that Beanstalk takes all of the services and kind of gives you a higher level opinionated API on top of them, but it never obscures the core services. So if we go into EC2, we see that there's our PHP environment. That's the EC2 instance for that environment, and we'll see 3 more instances pop up here pretty shortly. So, you know, if you want to terminate it or hit the system logs or change the security group, it's an EC2 instance that you want. So that's kind of, I think, important to know. So all first-class core infrastructure services are also in the management console. Beanstalk is just managing them for you. You don't pay to use Beanstalk itself. You pay for the EC2 instances that it runs, obviously, or the RDS databases, but the management service itself is free. So that's probably the first and last knee-based live demo I'm going to do. I'm too old for that. Questions, answers, let's do it.
Is it possible to run multiple containers within a single instance using Beanstalk?
Not today. Number one question that we get, running multiple containers. It's one container per host today. But I'm always curious to hear what your use case is. So what would the second or third, fourth container be?
Well, like if you're running some particular daemons, that might be doing something like routing your logs or your other data for you to do other types of stuff, and then just general restrictions of containers. Not always need a one. For sure.
Yeah, that's so daemons like cron-based stuff. It's really like a process of a container that runs every 5 minutes. Microservices, something that we're definitely looking at.
Yeah, for sure. Generally, I mean, Docker containers, some number of other containers.
Total. Yes.
Just as another use case for that, you know, we define containers for various portions of the application, worker container here, web container here, etc. In development environments, if we want a developer to be able to spin up a single instance to run a version of the application, we want all the containers on a single instance to make it easy and quick.
And that's a great use case too, is like consolidate them here, and then a deployment pattern that is maybe single host or maybe like spread out and wired together. Less expensive.
One of the things that we need to do is I know you can do this with Beanstalk with hosts, but we like to be able to do a rolling upgrade by spinning up Docker containers on a small number of hosts, and then start routing to those, and then like watch your error logs and then make sure that you get increased errors, and then as long as that's okay, keep switching over more and more. So that requires running, or at least being able to live change which one you're for sure running, and ideally you run both at the same time while it switches over.
Yeah, that's a great feature. Today, when you deploy a second application version or a new app version, we actually do Docker run and make sure that the container launches and that it's okay, and then it's around for like 2 seconds. And then we do the Nginx rerouting over there and turn it down. And you could imagine how you could extend that out to like A/B or split like 90-10% traffic.
So you can actually, when you do the new version, it doesn't like create new hosts like it does when we do it.
Correct. But there's lots of cool things that can and will we'll be looking at doing down the road.
So what about like a multi-tier architecture? So you have like web, app, database, everything done in Docker, not using Amazon services. Does the Beanstalk provide any mechanisms for like stitching those together, like you kind of showed here, or is that
So
by hand?
if you're doing your database in Docker, like if you're doing Mongo or Postgres in Docker, and say you're doing your load balancing or routing in HA proxy, Beanstalk's not the right place. I would look at OpsWorks. So OpsWorks is chef-based, and it has this concept of different layers. The Beanstalk is really, the Beanstalk concept is a load balancing layer, which is ELB, a web application, which is whatever you want, and a database tier, which is Dynamo or RDS. But OpsWorks is like you can own any of those layers. You can add layers that haven't even been invented yet. And there's some stuff happening in the Docker world there. Jonathan, as my colleague on the OpsWorks team, did a talk at DockerCon about what they're doing for OpsWorks. So I would encourage you to look.
So Docker would be recommended just for the app layer in this Beanstalk world.
Yep, Docker's for the app layer.
I just kind of added to his point. It'd be great if the Docker container would launch, and then you would hit that like a home URL to warm it up, because our app is unfortunately kind of have to get loaded. So that first request, just like start Docker container and warm it up, and then swap the ports on Nginx ports it. That'd be really helpful for us and kind of ensure it had zero downtime deploys are in place.
Okay.
That'd be great. I know you guys have rolling deploys too.
Yep.
So that'd be great. The other thing was I noticed the use of the Elastic Beanstalk extensions in the YAML file. And I've also seen you guys do a media project, an example blog post you guys posted recently, the nested templates, and calling Elastic Beanstalks from the nested templates. Is there like one you favor more than other versus writing YAML or calling CloudFormation with nested templates?
It depends on like your tolerance for pain. Like Jason and Jason. So he talked about this blog post series that we did for the sample application called the Media Manager, and I'll just I'm going to just pull that post up and kind of characterize this problem we were trying to solve with this fairly complicated application. So we said that we have this. Here's what this. We have this Java application that we've Dockerized, or there's a Java version as well. So you're familiar with like the little icon that I use for load balance, but it's like an enterprise app, which means it has VPC and all these security controls, and it also has a ton of other like dependencies. Elasticache is a managed memcached or Redis service. It needs to use S3, and it uses RDS, and it uses Elastic Transcoder and Identity Access Management. So it's a Beanstalk app with lots of dependencies, and it runs inside this VPC topology, this big network topology. So lots of moving parts. There's a lot of different ways to look at this. Some people see their VPCs as things that exist for a long time. Like the VPC is defined by the networking team, and it lives for a long time, for months or years. Other people see this as totally ephemeral. Like a VPC, even though it's a complex collection of subnets and routes and network definitions, it should be creatable and destroyable along with the application. That's the more challenging approach to take, so that's how we wrote this blog post. Like the idea is that the entire stack, everything should be runnable by a developer or an ops team without having to manually configure stuff. So it's totally self-contained. And what we did there was, when you're talking about these nested templates, we used CloudFormation. So I talked about CloudFormation as it's a JSON, it's a declarative syntax that is JSON-based that allows you to describe an Elastic Beanstalk application, like what the characteristics are. It's Docker-based, it's load balanced, it has a minimum number of instances, and CloudFormation also defines in a separate template the network topology, and then CloudFormation in a separate template defines the dependencies or the other resources. And then one template to rule them all is this master template, and it actually declares these substacks and sort of orchestrates this complex infrastructure into a version controllable JSON document. It was some work to get that done. Like, it's a fair bit of JSON to write, but I can give you a hyperlink right now, and everyone can just run this and get the exact same thing. And we can run it in Sydney, Tokyo, and Virginia, and Dublin. So when repeatability and reproducibility matter, when there are a lot of moving parts, or you see down the road that there will become more moving parts, CloudFormation is a pattern that I would strongly encourage you to use. Blog posts and stuff. I did a video series on that too, so go through it, and we worked really closely with the CloudFormation teams and all these service teams to say, like, this is the right way to do a large scale. This is a media sharing and conversion service, sharing video files with a beanstalk app and all of these data stored back. So it was the blog. Yeah.
The EB extensions config file that you were showing earlier for beanstalk looks very much like the CloudFormation template, but in YAML instead.
It is, yeah.
So, I mean, you can write the CloudFormation templates in YAML and just parse it into JSON.
You get comments that way too.
That's what I'm trying to do right now, and some other stuff, but
yeah.
I'll ask you.
Yeah, so EB extensions, and we can maybe like sidebar go into why it looks like CloudFormation. EB extensions, I like YAML. We try to parse YAML first on the back end. It will accept JSON, but no XML. Good. Yeah. Right. No one's ever asked for that, so I expect they will. Yeah.
Is it possible to change the Amazon Linux AMI that's being used for the host OS? So the project I'm working on right now, we're looking at using CoreOS. So if I wanted to use CoreOS, I know there's an AMI available, but would Beanstalk allow me to use CoreOS?
So we have a base AMI that we launched the EC2 instances on and Bootstrap Docker into, and you can customize that. So in configuration, under instances, you could pick a C3 large and put a custom AMI ID in. So there's this sort of like two prongs to this. Yes, you can change the AMI. It's not going to work. So we know, we have an expectation of what userland looks like and how we would bootstrap and what's installed on Amazon Linux and how we bootstrap into it, and CoreOS doesn't fit that. That said, we get requests for CoreOS, Ubuntu, and RHEL as base host support, and we're evaluating those. So you can change it, but don't expect anything good to come from it.
On that, would it be possible, like, I mean, it's probably not available now, but even though you have expectations, I assume that if you had an option to just disable the bootstrapping and assume that, like, if we knew what the API was to be like, oh, you need to have a web server listening like this, that can connect, and then this, if you want to have these agents running, the person configuring the system would do such a thing.
Right.
And especially if you use Docker, so that would do all of that.
Yes.
So just being able to disable the bootstrapping might be nice.
Yeah. So unfortunately, we thought long and hard about the bootstrapping 3 years ago, before Docker existed. We're reconsidering it. Because the bootstrapping itself is like an API. And there's a contract in like the order that things happen in and where they happen. And we just right now happen to own all of that. And we're thinking about how we could almost define the events that happen in Bootstrap and ask you, like, what do you want to do here? What Docker container do you want to run at this tier layer? We're tossing these ideas around, but nothing hard and fast right now. But it's good. It's good validation to hear this from the community. So this goes till 8 o'clock. It's gonna be weird sitting here for 14 more minutes in silence. Yeah.
I noticed when we make the API call to import the application, it writes to SKSU, and it seems like as you can see it from the hub to then export application across all the nodes. Is there a way to manage all that so we deploy our application on one node only, so kind of test one node out of like 10?
Very savvy. So yeah, we use CFN under the hood to basically do what we call a command service. And there's not a way, right, that we don't expose the command service API. So you would want to like deploy a new version
Like a new branch, just to test,
to
one
test,
node,
okay.
until you guys get that kind of gradual rollout and working.
Yep. Yeah, the problem there is it's non-deterministic, so between calls you wouldn't know like which one you were getting if we enabled that. So I don't think there's not a good story there until we get kind of like rolling out version deployments. I wouldn't even encourage you to try that.